Okay, hello, welcome everyone to the meeting of the working group on contributing MicroJIT to the OpenJ9 project. Today is February 11, 2021. We have no formal agenda, so whoever wants to start is welcome.
Perfect. So I guess I'll get started. I'm digging into creating my own empty CFG. I've got some examples of how to do that. And I've kind of done up a bit of a skeleton of how I'm going to approach actually making the CFG. So the example code snippet I had was from estimating code size. There was a get block thing that would check to see if a block had been made already in an array. And if it hadn't, it made an empty block. And then set it up, connected it properly in the graph. And then, or sorry, not connected properly in the graph. It would create the block and set up the block so it had a start tree and an end tree. What we're looking to do is make a full CFG out of this. So I'm imagining that what we really want is to somehow be able to associate a bytecode index with a block, which shouldn't be too hard to do. Given a CFG, we should be able to figure out where which block an index belongs to by just looking at all the nodes in order. If they have a start index, then we know if we order them based off of the start index, as soon as we find the one where n+1 is a bigger start index than the index we're looking for, then we know that block n is the block that contains that bytecode. And then for creating edges, it's just anytime there's a branch, there's going to be the need to create an edge that connects the current block, which as we're creating these blocks, once we find a branch instruction, that should end the block because these are basic blocks. And that edge should point to one target because the jump is going to have a target. And then the next instruction is either going to be another jump instruction of some kind, or it's going to be a non-jump instruction. If it's a non-jump instruction, then we check to see if we made the block already, and if not, then we create a new block, and then we join it to the previous block. Then the last thing is if it is a jump instruction, then we're going to have to keep making jump instructions or edges from that first block to whatever the target is. So that's where we are right now, is we have this kind of skeleton of code. The problem that we have right now is that this is going to require some dynamic allocation. We want to create, we want to do as few passes over the bytecodes as possible. So we don't want to figure out how many bytecodes we need ahead of time, or rather how many blocks we need ahead of time. And we need to know how long to keep this thing around. So we can either look at a worst case scenario and say, all right, well, at worst case, we're going to need a block for every bytecode. We'll never exceed that amount. And there's probably an even better worst case analysis we could do to get an upper bound. And then from there, create a table of them. But then because we don't know how long these blocks actually need to be around, if we need the blocks or not, when we go to look at the profiling information coming off of the code that was generated from MicroJIT, if we need to keep that graph around, then we'll need to do the correct allocation there. So I'm hoping to figure out today when the CFG is created, what is the lifetime of that control flow graph, and whether that control flow graph is heap allocated or if there is some amount of space saved for it in some other object. Basically, where is it made, how is it made, and how long does it live for from a memory perspective, not necessarily from the nuts and bolts of how it's made, because that I now know is being done in the Walker and the IL gen.
Yeah, so memory is allocated recently with what we call regions. Maybe, Erwin, do you want to hop in on the discussion with the regional allocator?
So you want to figure out like what's a good way to allocate the blocks? Like what's the right thing to use?
Yeah, essentially, I want to know how to allocate space for the CFG and the blocks, and how to ensure that they are collected at the correct time or destructed at the correct time.
As soon as possible, basically.
When you say as soon as, okay, so I mean, right now what happens, I mean, I'll talk about what happens in a regular compile. I think the CFG and stuff is not allocated. It's allocated in sort of the compilation memory, which does get freed at the end of a compilation in like a bulk free approach. Is that as soon as possible, or were you thinking of something like within the scope of the compilation itself, like something about like when you get to code gen, you want the memory freed?
At the very least, that identifies for me that we don't need to leave the CFG around after the compilation is done. And if that's the case, then possibly be a little more creative about where and how I'm allocating it. Because a lot of the data structures we use in MicroJIT right now are allocated on the stack. And then we simply pass pointers to those things in function calls so that they go, they're allocated in the stack pretty far down the stack so that all the things that need to use it have access to it. And then we never return those pointers from where they're created. So it's just on the stack until compilation is done. And once the MicroJIT compilation is done, all those data structures are just popped for free.
When you're saying on the stack, it's the C stack, right?
Yeah, and the C stack,
Okay.
Right. Okay. I mean, so like you guys are doing the compilation in a similar way where you have like you've created the segment provider and all that kind of stuff, right?
I believe so. Yeah. They use a lot of infrastructure that exists today. So,
Okay,
we look in right at the wrapped compile method.
Right. Okay. So then, in that case, when you can use region, it's fine, because when you exit from that wrapped compile, because the segment allocators and everything are all locals, the destructor will free all the memory.
Okay, that sounds good. So
I mean, it'll hold on to it during the unless you're really you really require that memory does not stay, is not held for longer than like a sub process of the compilation. Like for example, you only want memory during optimization, but then when you go to code gen, you really want the memory gone. You could just use region. If you really wanted that situation, you could sort of create another region inside the compilation. Does that actually free memory though?
I thought we have something similar to what was our stack memory. So you could allocate, again, I'm not sure the right terminology here, but we had the stack memory. So if you use stack memory at the beginning of an optimization, and at the end we release that stack, then you are only using memory within an optimization. Maybe
that's true, but not 100%, right? So there is a stack memory region. It will return the memory, but it may not go back to the OS necessarily. It has to.
Right.
Like it may have been part of just like the memory it'll go back to like its backing provider, and if all the memory is in a segment, I believe if it's one of those big segments, it'll return it immediately. But I think if it's a small segment, it holds on to it.
Okay.
So in terms of like releasing it back to the OS, like from that point of view, it's going to be. I don't know if there's an easy way to guarantee that without going into the memory internals. But for the purpose of what you want to do, you could take the way Testarossa works for just regular compilations. It just uses region, and because you're using the same sort of methodology of creating the segment providers and everything on the stack as like RAII objects almost, the destructor will just clean up all the memory after that.
Okay, so it sounds like to me that I can, for all the dynamic allocation I want to do, I can just reuse those regions. It'll get cleaned up at the end of the compilation, and that's already what's being done with the CFG as it currently stands, which means that I shouldn't need to keep that CFG around in any sort of memory space that doesn't get cleaned up after compilation for the optimizer to later on, when TR comes in to get profiling information to use for its own counter placements to continue its profiling, it should be able to recover that information through where we're storing the counts, which are not being stored the same way. They're not being stored inside the CFG, so it's getting that information probably from that same location somehow.
Yeah, I think like all the block frequencies and stuff. If it is in the CFG, I believe they get like for something like J profiling. I think they get put in the persistent info afterwards because
Yeah,
the CFG is very transient. Sorry, go ahead, Rail.
yeah, that's you're correct there. Yeah, it has its own persistent memory that we keep in, and for an example, for the J profiling block frequency, we have a like block frequency info which is persistent throughout the JVM. So we store the information there in a series of bit vectors.
Right, but the CFG itself, it's allocated with memory that only lasts during a single compilation. And you shouldn't share that with memory
No.
for another compilation.
No, I don't think so. We do that.
Yeah.
The only way CFG is used is to find out the counter placement. I don't
Right,
think so.
right.
Once we have decided that information and decided where we want to put counter, I think we won't need CFG.
Yeah, so Scott, I don't think you should be worried about the memory that is used for the CFG. And by the way, how big, have you computed how big these CFGs are or how much memory they take? Because I don't think they should take that much space.
Well, the code samples that I'm looking at, I haven't looked at the CFG object, but what we're working with, what is mostly going to take up the space is going to be the blocks. And the blocks have a lot of extra information in them that we're not using, but that's fine. We're incurring that penalty and we're comfortable incurring that penalty. I just wanted to know if there was a convenient and easy way to, if I needed these CFGs around, I should say. If I needed them around after the compilation, well, then I was going to have to do it the dynamic way anyway. And B, if the dynamic stuff was being cleared up afterwards at the end of compilation, then there'd be no worries about taking up a lot of system memory with inefficiently large control flow graphs because we're not doing any optimizations on them. So we'd have possibly a lot of blocks and edges that in other examples or CFGs for a similar method that have run through some optimizers in OpenJ9 TR, they would have comparatively smaller graphs because there's going to be less branching, and I assume that TR is going to do a lot of dead code elimination and a lot of other things.
So I don't know if the CFGs are designed to live outside of a compilation right now.
No, I
No.
don't think, I've never heard of that.
Yeah, and that was what I was. That was what I didn't know, was did I need to keep this around or not? Not that I was
No.
looking to keep it around. I just didn't know if I need to keep it around, then the idea of allocating on the stack is just immediately already gone, and it needs to be dynamic. And it sounds like the dynamic thing's not as much overhead as probably I may have feared, because if I was doing it on the stack, then I could clean it up very quickly because it would all just happen as part of like a pointer decrement.
Also, I have a question. So, do your blocks refer to trees? Because I thought you don't use an IL generator, therefore you have no trees.
True, but basically the way that the blocks are created, the blocks themselves still need a tree of some kind inside. And so the code I was pointed at to by VJ points at the creation of a block that doesn't actually have an IL tree inside it in terms of anything that is usable to discern what the code does. It instead just creates a start tree and end tree. So it creates a BB start and a BB end, joins the start to the end, and creates a block from that. So that's the code snippet that we're going to be using to create blocks. And then we'll be simply attaching these empty blocks together in a CFG so that we can do our edge placements.
Yeah, I got it now. Okay, thanks.
Right, so that's it for me. It sounds like I've got everything I need to do this CFG creation, and hopefully I'll have this profiling instruction emitting code at least in the debugging stages by next meeting, if not reporting values and seeing how it and being able to describe how it works.
Yeah, perfect.
I should note that if your CFGs and stuff, to require the TR memory as a parameter to, like do the placement news and all that kind of stuff, it's all fine because the way the compilation works right now is everything is at the end of the day backed by region.
Okay.
So you don't actually have to go for region directly if you don't want to. Like if it just simplifies the code to just use existing constructors, it doesn't matter because like unless you go out of your way to like try and find persistent memory, like TR memory for that compilation will use region under the covers through some complicated series, but it's all still going to be cleaned up.
Okay, perfect. I just didn't. My biggest fears were not having it live long enough and causing a null pointer exception. Even worse if it was part of something that ended up being asynchronous and therefore it would be a non-deterministic error, or vice versa, causing a memory leak where I would be having something that I needed to clean up that wasn't being cleaned automatically, just floating around. I wanted to make sure I avoided those two cases before I got started. But it sounds like I can just use those regions for any dynamic allocation, and I can then more or less kind of fire and forget.
Yeah.
Great. Perfect. I'll hand it off to Harpreet.
Okay. So before I start my update for today, I would like to welcome Georgie. So he's a new member to our meeting today. So some of you might already know him. So he's our fellow student at CAS Atlantic, and he's a member of the team who is working on the AOT compilation. So welcome, Georgie.
Yeah. Hello, everyone.
Yeah. So Georgie is helping me with the Jenkins builds. So what happened is, so we have our changes in the OMR. So they have already been tested on the 64-bit, but the 32-bit is, I mean, the current path was going, it was taking so much time when I was trying to do it on the Windows. Because the Windows and the 32-bit combination, that is pretty scarce. So when I got the OpenJ9 building on the Windows, then I was like trying to get the test framework running, trying to get my changes tested using that test framework. Then it was like some new problems are creeping up. So I just thought of going by the Jenkins build. So the main problem in that path was neither me nor Scott has the access to the IBM VPN. So Georgie has the IBM VPN access, so he's currently helping me in that. But we have some concerns. I would like to ask whether the PR in open on the Eclipse OMR repo, so can it be tested with the Jenkins, or we'll have to keep it on the like IBM Enterprise GitHub?
So the PMR not PMR. The PR is in OpenJ9 or is OMR?
No,
It's
that
OMR.
is in the OMR. Yeah, OMR.
So I think that anything that's in a PI can be tested, and I don't do that much testing these days, but I think the Jenkins infrastructure puts the Jenkins infrastructure. There is a lot of noise from somebody.
You might want to mute.
Okay, so you could use the Jenkins to point to a particular build of yours and a particular OMR build, and these two will be packaged together and sent to the testing infrastructure, as far as I know. As long as you have them in a repo that is accessible, so it doesn't have to be even in the original OMR repo. It can stay in your own repo, and you can test from there as well.
So basically the question originates from here. Like usually I test it by having my own repository that is public in github.ibm.com. So it's behind the credentials, right? And I just point Jenkins to that repo to test because I find it the fastest.
Right. Mm-hmm.
Yeah, and essentially the concern about change of permissions, I think, when I said that it's most convenient way for me to test it, Harpreet raised the concern about the permissions. Is that okay to keep doing it this way? Like keeping the repo was like public permissions behind the W3 ID credentials for Jenkins purposes.
Okay. So basically you have an IBM repo, and the question is whether or not you should give permission to the Jenkins framework to access your repo.
No, I just leave it open, so Jenkins has access by default. Like I was advised by person who was, I think it was Shirley Lambert, who said you can leave it open or you can configure the combination of keys or find the person to configure the repository. So I chose to leave it open, but Harpreet is wondering if it is okay with their team to do it the same way.
Yeah, I'm not sure what our policy is, and my code does not live in IBM repo. Whenever I test something, I'm not testing from the IBM repo. I'm testing from my GitHub public repo. I don't know if it's okay with IBM legal.
Sorry, I'm not sure I still understand. So you've got a repo within the IBM GitHub Enterprise,
right?
And you've opened it to beyond IBM runtimes, like you're basically making it public within IBM.
I did not. When I created the repo, there was option make it private, make it public.
Okay.
It's only accessible through with W3 ID credentials.
That's fine then. If it's public for everybody within IBM, it should be fine. I was wondering whether you made it public outside IBM.
No, I did not.
Okay,
right.
And I think that's fine.
And even making it public outside of IBM is somewhat your call, right? Like if you are okay with disclosing what you have, that's, I mean, in part your decision. There may be some, like if you are planning on patenting something in this design, or if there was some research that you're doing that you did not want to disclose early, then you may want to protect it. But if you don't have if there's no issue with you doing all your work in the open, then you can certainly do it that way. But anyway, what you just described with the way you're working within IBM is just fine.
Okay.
The other thing that I'll say is that, like Harpreet, if you really need access to Jenkins in order to do the build yourself without having to go through Georgi, you should be able to request it.
Yeah. So we are currently in the process of like we ordered the machines, so they are under processing. They will be with us in a couple of days, I guess. But for the time being, we just thought of not wasting the time and just requesting the services of someone who already has the access to the IBM VPN.
Yeah, I don't mind helping, so yeah.
Okay.
Okay, thank you.
Okay, so what I take from this is we can have our repository at the github.ibm.com, which can be declared as a public. So that will be within the purview of the IBM members only. So that is not an issue to make it public. So if like Marius earlier said that we can also go through, we can directly test the changes on the PR, which is currently open in the Eclipse OMR. So for doing that, if I decide to go through that, is there some documentation for that? Because I got something in the repository, which is at the Adobe OpenJDK. So it says that we can do it through the OpenJDK tests repository. So like, do we have any documentation in this regard, or do we have to do it through this OpenJDK tests? I mean, something, some.
Don't remember.
pointers.
I have some instructions that I collected for myself from various people. I'm not sure if they should be published somewhere. I'll try to search it for you.
Okay, all right.
Okay. If not, I'm going to share the whatever documentation I collected privately.
Yeah, okay, that will be good to go. And that's all I have for today.
I just gave a quick double check and I went through our IBM or GitHub IBM.com repositories, and I didn't see anywhere whether it said whether they were public or private, but down in the quote danger zone unquote options, there was a button to make it private. So I assume it's already public from the everyone in IBM can view it perspective. Which makes sense because I believe there was a question that we had a long time ago, and someone asked if they could see the code, and we gave them the link on GitHub IBM, and that they were able to use that, and they were not already added as a contributor to the project. So it sounds like it's already public from the perspective that was described as public to inside IBM.
Okay, good. One thing that I wanted to mention, Harpreet, it may make sense to try to test a Win32 build without any of your changes, right? Because that in itself may fail. I'm not sure how well we test Windows 32 or if that is supported. And we don't want to, have doubts that it doesn't work because of your code or because it just doesn't work.
Okay, so in that regard, I already tried building the OpenJ9 on the Windows 32.
And
So
it did work.
it did work a couple of days before, but when I tried doing that a day or two ago, now it's again failing. So that is the main reason why I stopped that path, because I guess when one thing is done, I just get hooked on the another one with the Windows thing. So that was my concern. But I can say for sure that the Windows 32 thing is working.
Okay.
So, from my experience, sometimes you have to just until the changes that might be introduced to OpenJ9 that break, say, OpenJDK build for some time, or to OMR. That's more likely the case. you have like I usually used to take two commits that build together and rebase my changes on top of them, and also schedule builds on top of the newest commits on the main branches, just in case to see if the problem has resolved itself. So testing is not as simple. Yeah.
So if you combine what the OMR OpenJ9 with OpenJ9, that should work, right? So we have a repo where all the OMR changes that have been promoted will be moved to this OpenJ9 OMR. Instead of combining directly OMR with OpenJ9, you should combine OpenJ9 OMR with OpenJ9.
Okay, so that means the repository OpenJ9. No.
So there is something
OpenJ9
called OpenJ9 -OMR.
-OMR. Okay, all right, I got it. Okay.
That's the one that you want to combine with OpenJ9.
Okay, that makes sense.
Okay, any other topic?
No.
I think everything's good on my end.
Okay, thank you guys, and thank you everyone for participating. I guess we can stop here.
Perfect.
So next meeting is in 2 weeks on February 25th at the same hour.
Awesome. Thank you everybody for coming, and thank you for your time.
Thank you. And,
Thanks, bye.
Thank you.
I'll post it to YouTube as soon as
Thank you.
possible. Okay, bye.
Bye.
Bye.